Hey Calculus, we are starting chapter 10, our last unit. Right, here we go. We are going to learn about the difference between distance and displacement. Okay, so in this box right up here, we have the difference between distance and displacement. Okay, distance is how far you travel. Displacement is how far and in which direction. All right, and then we also need to know the difference between speed and velocity. Speed is, of course, how fast you're going, but velocity is how fast and in which direction. Example number 1 gives us a nice example of the difference between displacement and distance. So, say we start here we are, and we are going to drive 100 miles. Okay, so we drive 100 miles out. Okay? But now, what if we turn back and drive back 70 miles? Okay, so we drove back 70 miles. All right, well, where did we end up? We ended up 30 miles from where we started. Okay, that's where we ended up. All right, so our distance is how many miles did we drive in total? Our distance is 170 miles. We drove 170 miles. But where we ended up is our displacement. All right, our displacement is equal to 30 miles. All right, so that's kind of the difference there. Displacement is 30 miles. All right. So again, our total distance is 170 miles, and our net displacement is we ended up 30 miles from where we started with, right here. Okay, so now I'm just going to read through this. Although you have gone a distance of 170 miles, your displacement, which is measured from the starting point, is only 30 miles. Okay, good example. We're going to look at example number 2. We're going to be swimming. For all you swimmers out there, we have quite a few of you. All right, so we are in an endurance swimming contest. That means a long-distance swimming contest. We're swimming upstream for 10 minutes. All right, the river flows at 30 feet per minute. Calvin jumps in and starts swimming upstream at 100 feet per minute. Phoebe figures that as Calvin gets tired, his speed through the water decreases exponentially, and this is our equation, so that would make sense. This is our graph, all right? So here is our time along the x-axis, and this is our velocity along the y-axis, and we are definitely, our velocity is decreasing as time goes on. We're slowing down, we're more tired. So part A, at what time has Calvin's velocity become negative? Well, it's negative right here, below the x-axis. So we just need to find that x-intercept, all right? So we can set our velocity equal to 0. So we can take this equation right here, and we can set it equal to 0. So we can set our velocity equation equal to 0. All right, so 0 is equal to 100 times 0.8 t, and it's equal to, or minus 30, excuse me. All right, there's our equation. Now, we could definitely take the time to solve this algebraically, but we are not going to do that right now. We are just going to use our calculator. All right, so use your, hold on, my kid is playing Minecraft again. He's really loud, driving me crazy. But this is why I usually do videos at night, but then I'm too tired. All right, so let's get back on track here. He's quieter. We are going to use the calculator to find our x-intercept. All right, so graph that. Use the intersection function, because guess what? It's not a whole number. All right, so I'm getting t is equal to 5.4 when I graph that. All right? Okay, so now we're going to move on to part B. How far? Highlight that. Underline that. Whatever you have to do, but that is a key word. What calculus concept tells us how far distance traveled? That is an integral. And hopefully you remember that. That is an integral. Symbol for integral is our big elongated S. So whenever you're asked for how far, we are going to be setting up a definite integral. So how far will Calvin travel upstream? That is, well, his velocity is positive. Well, his velocity is positive right here. Positive is above the x-axis. All right, so I'm going to highlight this up here. All right, so here we go. Right here, if you're above the x-axis, that is positive. All right, And then if you are below the x-axis, that is negative. All right? So for question part B, right here, how far will he travel? Well, he is upstream while the velocity is positive. What are my endpoints? Well, my left endpoint is going to be 0, and my right endpoint is going to be that x-intercept at 5.4. So those are my left and right endpoints. So the 0 goes here, and the 5.4 goes up here. And then it is the integral of the velocity. All right, so that's got to be dt. So this is going to be from 0 to 5.4 of 100 times 0.8 to the t minus 30 dt. So whenever you see how far, you will be setting up a definite integral. Okay? Now, let's just go off to the side and let's remember the names of our functions. Remember, f of x, our original function? What are the two names for the original function? Well, it's called displacement in the calculus world. And also, if you remember, the other name that it sometimes is referred to is the position function. So we got to remember that. Our derivative, f prime of x, that is, of course, our first derivative. But the real world name for that is our velocity. All right? And then let's just review our second derivative, f double prime of x. What is the real world name for that? If you said acceleration, you are exactly right. Now, why do we use a definite integral when we're asked how far and we're given as velocity? Well, how far we're traveled, we're trying to get to our displacement. We're given our velocity. So to go backwards, remember, that is an antiderivative. All right, so hopefully that makes sense why we use a definite integral here. And again, you just have to be on the lookout for those key words, how far. All right, well, we could use the fundamental theorem of calculus for this, or we could use Math 9. I vote Math 9. You're welcome. All right, Math 9. What do you get? I'm getting, do that real quick. Do it, don't copy my answer. I'm getting 151.83 feet. You have to label your answers. Feet, okay, there we go. So that says how far. How far is a definite integral. Okay, part B, how far will he travel back downstream? Well, his velocity is negative. Okay, so again, we see how far. All right. So how far? Again, that's a definite integral. So we use our definite integral. When our velocity is negative, that's up here. That is from this left endpoint at 5.4 all the way to the right endpoint. So we start at 5.4 here. And what is our right endpoint? Well, our right endpoint, we have to go up here and look at our problem right here. A period of 10 minutes. All right, so this is 10 out here on that x-axis. So my left and right endpoints are 5.4 to 10. We take the integral of our velocity equation, 100 times 0.8 to the t minus 30, and don't forget dt. You need correct calculus notation. All right, so let's Math 9 this guy. So again, you do that on your calculator. I am getting negative, and we should get negative because it's below, so we should get a negative answer. So I'm getting negative 51.81, and that of course is feet. So again, if our graph is above the x-axis, this area right here is positive. In fact, I'm going to shade it in right here. This is a positive area. All right, I probably should have put that positive right here for you guys. Positive. All right, and then the area, so that's why this answer right here is positive. And now our integral from 5.4 to 10, that area, I'm going to highlight it for you. That area is below the x-axis, so that, of course, is why we are getting a negative answer. Okay? All right. Now, for part C, we want the total distance traveled. Okay? Now, I'm going to underline that, total distance traveled. distance can't be negative. All right? So we have to take our first answer from 0 to 5.4, 151.83, and we have to take it, add it to our second answer, negative 51.81, but we have to take the absolute value of that because distance can't be negative. All right? So when we add these two together, we are going to get 203.6 feet. So again, 151.83 plus the absolute value of negative 51.81. Remember, absolute value makes everything positive. So negative 51.81 becomes positive 51.81. And that gives us 203.6 feet. Okay, so again, let's recap. We found the how far he traveled in our first interval from 0 to 5.4. That area is above, so we got a positive answer. We found how far he traveled from 5.4 to 10. That area is below, so we got a negative answer right here. For the total distance traveled, distance cannot be negative, so we have to take the absolute value of this interval and add them together, and we get 203.6 feet. Okay, again, distance can't be negative. All right, now the next thing we're going to do is we're going to find the displacement for this interval. All right, so we're going to see you on the back side. Okay, now we are asked to find displacement. Okay, displacement. Now, displacement can be negative. All right, it can be negative. Okay, so now we don't have to take the absolute value of that second interval. So our first interval was from 0 to 5.4, 151.83. Our second interval from 5.4 to 10 was negative 51.81, and we simply add them together. And we get, let's see, I'm getting 100.02, and that is feet. So that is our displacement, okay? So again, distance can't be negative, so you have to take the absolute value of any negative answers. Displacement can be negative. All right, let's look at the next part. Will he be upstream or downstream? All right, well, I'm thinking that because our displacement is positive, that means that we end upstream, okay? So we are going to circle upstream. He is upstream because his displacement is positive. All right, positive 100.02 feet. Okay, all right. Let's look at the next one, part D. We are going to write a definite integral that you can use to find this displacement after 10 minutes in one computation. All right. Okay, so then rather than splitting it up into two intervals, positive and negative, we are going to just write one integral, all right, from 0 to 10. And we're going to put our velocity in there, so 100 times 0.8 to the t minus 30, and then dt. So we're not splitting it up into two separate intervals, we're doing one interval. All right, so I think we should use the fundamental theorem of calculus here, so we can't forget that. All right, so we are going to use the fundamental theorem of calculus. If you remember, the first step is to find the antiderivative. All right, antiderivative. Okay, so let's break this down. 100 is a coefficient. It comes along for the ride. Now we need to take the antiderivative of 0.8 to the t. Well, that's an exponential function base 0.8, so you have to go to your flashcards. All right, that becomes 0.8 to the t. We write the function again, and we divide it by the natural log of the base. All right, so again, 100 comes down. That's a coefficient. The antiderivative of 0.8 to the t using our flashcards is 0.8 to the t divided by ln8. Now we keep going. The minus comes down. And the antiderivative of 30 is 30t. Again, you need your antiderivative power rule for that. And then we use brackets to remember our limits. All right, the second step for the fundamental theorem of calculus is we take the upper limit, which is 10, and we plug it into the antiderivative. And then we subtract off, we plug in our lower limit into the antiderivative, minus g of 0. So my advice is to, again, put your antiderivative into y equals and find these values. All right, so when I plugged in 10, I'm getting negative 348.1. Now you have to be careful when you're plugging this into your calculator because you need parentheses around that fraction, but when you hit natural log, it starts a parentheses for you, so you have to remember to end that parentheses. So you need 2 sets of parentheses for this guy here if you have the older calculators especially. Okay, when I plug in 0, I am getting, hold on, I gotta scroll up, way up to 0. I am getting negative 448.1. So be careful, this negative is not the same as this minus. Now when I subtract those, I am getting 100 feet. Now that is pretty darn close to what I got up here. All right, when I added my 2 intervals together. Remember, this was my 0 to 5.4, and this was my 5.4 to 10. When I did 2 separate intervals and added them together, I got 100.02. When I did 1 single integral, I got the same answer. Okay? All right. Now check your work with Math 9 and get all that done. To check with Math 9, remember, to check your work, you use the original equation. Use original equation. All right? All right, so you go ahead and do that. All right, now the next thing we're going to do is we are going to write a single integral to find our distance traveled. All right, so we need a single integral, from 0 to 10. We need our velocity, okay, which is 100 times 0.8 to the t minus 30 dt. But now remember, distance traveled can't be negative. So, and this is huge, you guys, when you are doing distance traveled in one integral, you have to put absolute value around your velocity equation. All right, you need absolute value. All right, now you absolutely can use Math 9 for this. All right, now when I do Math 9, I am getting 203.6 feet, which is exactly what we got when we broke it down into 2 separate intervals. If you remember on the front side of this note sheet, when we did the first interval, I'm going to kind of go off to the side here, from 0 to 5.4, remember our answer was 151.83, and then when we did from 5.4 to 10, we got negative 51.81, but we had to take the absolute value of that. All right, and when I add those 2 things together, I got the same answer. All right, so there's our notes for 10-1. You can do distance and displacement both by splitting it up into separate intervals, positive and negative, and adding them together. And you can do one single integral. You just have to remember that if you're doing 2 separate intervals, you have to take the absolute value of the negative one whenever you're doing distance traveled. All right. Right now, you should also do the 10-2 notes, and there will be there's a video for that on Google Classroom. All right, take care, calculus.